The FASS Flight Management Control Unit spans the vast area of operational flight monitoring, station management, and disruption repair. In a passive mode, it receives real-time events from the airline's worldwide operations via either internal messages inside the FASS system, from other instances of the FMCU that are in use, or from IATA standard movement and ad hoc schedule messages from outstations that are not online users of the FMCU. The system monitors the status of flights near to the current time. It flags via colors and also via the problems list issues that arise from the real-time operation. The typical problems we see are that estimated and actual times are missing from the flights. In station management functionality, the user updates the times and operational activities of the flights on the chart. We will update a flight and set actual times now. The flight departs late, so we are also going to set the delay reason. In a second example, we set the estimated times on a future flight that has not departed yet. Again, we will set the delay reasons on the flight. In addition to such actions which represent typical normal operation, the FMCU also permits a variety of diversion actions. In particular, flights can sustain ground returns where they push back from the chocks but then return without a takeoff because of a technical problem. They also sustain air returns where they return to the takeoff airport soon after going airborne, also usually for technical reasons. There are also in-flight diversions that can be affected, like changing an en route airport, removing an en route stop, or altering the destination airport, either with continuation to the original destination or with termination at the new airport. All of these actions trigger the generation of IATA movement messages. In an alternative scenario, incoming IATA movement messages can trigger the same flight actions as we effect via the FMCU program. When operational actions arrive from outside FASS, for example from IATA movement messages, the user is placed in the position of taking remedial action to fix problems that arise from these external activities. A flight might depart so late that its arrival will either allow insufficient ground time at the next airport or would then overlap the next scheduled departure. Or the station manager at an offline airport might decide to cancel the operation of a flight altogether because there is no foreseeable likelihood of the aircraft becoming operable in a reasonable time frame. The operations controller using FMCU must fix the schedule to make it operable again without the cancelled flight. There are many actions that can be taken, like cancelling the next flight, moving flights onto other aircraft, and possibly then also adding a positioning flight to reconnect the schedule. The action taken will depend on the controller's experience and on airline-mandated practices. However, he may also use the intelligent rescheduling system to try to fix the problems. There is another presentation about that, so I won't say more about it right now. The FMCU is thus both a monitoring and management toolkit. Besides the few functions we have looked at briefly here, it contains extensive tools for managing pre-flight operations, inspecting passenger and crew connectivity, and predicting delays based on historical flight profiles. All of these functions need custom configuration based on an airline's standard practices. And linked to the messaging backend module, it provides both incoming and outgoing IATA standard real-time event processing.